Welcome, welcome. If you can hear me, please let me know. I'm just pulling up this real quick. I should be live, I'm hoping. Let me put this on mute. If you can hear me, let me know real quick. Let me know how quality sounds. I got a nice mic this time, so everything should sound good. Uh, Way better than the other live streams. Let me just pull up the live stream over on this side. That's it. Okay. What is going on here? I think I got it all working. Got this over here. Okay, let me give a few minutes to have some people get in here. Let me know if the mic is too loud, too quiet, or if it could use anything. It's good? Okay, that's perfect. Perfect. This is a new mic, so I wanted to make sure everything sounded good. All right, let me get my OBS set up. All right. I'll give it a few minutes to get a few people in here. It has likes. It has 4 likes. But, oh, there's some people in here. Okay. So this is just a quick live stream after that one video I just made. I hope you guys enjoyed it. I have my computer down here, so this is a camera. I'm probably gonna be looking down at my computer mostly, because this is where I have everything, my OBS set up. I got some behind the scenes pictures to see if any of you guys want to see that type of stuff. Of Mega X, which Mega X is my next rocket motor. It's gonna be crazy. It's gonna be way bigger than any of the SN series. I know you saw that little snippet at the end of the video, but I can show you some other things. Yeah, you guys saw that snippet. That right now is Mega X casing. Right now it's measured at a 3.5-inch inner diameter. Um, I'm possibly thinking about going bigger, but that's what I have it set at right now. Here's just a front view. The other one was an isometric view. Um, yeah, it's gonna be way bigger. I'm hoping to do around a little less than 500 pounds of thrust. Right now, if we go to my simulation, this is just some early simulations I've been working on. Um, this simulation did around 375 pounds. I'm not 100% sure exactly exact conversion to kilonewtons to pounds. But also, if let me know if the live stream's lagging because it's saying warning on my screen that it may be lagging. But just let me know. But yeah, this is an early simulation I did yesterday. Um, Obviously, this is going to change a lot as time goes. I'm only about a week into designing it, and a week of on and off of designing because I've been working on the other YouTube video. I've been working on that video a lot. Um, yeah, that video is a lot of work. But yeah, this is pretty much what we got here. Um, we're keeping, as you can see to the left, we're using the same type of grain geometry with the finisil at the facing towards the nozzle, as we just tested on SN5's last test, which, well, not last test, but its only test, but my last test of the SN series. Uh, so yeah, we're keeping a finisil towards the nozzle, and then we're also just gonna have a normal Bates geometry with just all single casted grain. Let me see what else I have up here to show. Here's the nozzle geometry. Not much to show right here. This is probably going to change a lot. This is just what I have right now, which is just pretty basic. This is pretty basic nozzle geometry with a 15-degree diverging half angle and a 30-degree converging half angle. I may change the throat diameter and length quite a bit depending on thrust levels and pressure levels inside of the casing, because those are very important. Right now I have it maxing out at, I think, very small. Yeah, maxing out around 519 psi, which is totally acceptable, and it's totally achievable. So that's why I may push up the pressure a little bit higher than 500 psi, because as we saw with SN5 got up to what was it? I'm sorry. Um, whatever. Yeah, SM5 got up there, so it's definitely achievable. With we're also going to be using a thicker casing because this rocket motor, although we're gonna keep it as light as possible, we can beef up the casing because this rocket motor most likely will never fly. Maybe if someone wants to fly it for me, I don't have the certifications to fly these rocket motors, but that is kind of a shameless plug or whatever you want to call that. If anyone can fly these rocket motors, let me know because I will gladly send you over one of my rocket motors to fly, fully ready for flight. But yeah, this rocket motor will probably never fly. It's gonna do around, I'm hoping around 500 pounds of thrust. Right now with the simulations, we're getting around 350. And obviously simulations always work out usually better than in real life. So that's what we got there. Let me see if I can find anything else. Well, I got a bunch of other things. The nozzle. This is very early prototyping of the nozzle. It's, oh, what did I just do there? Um, this is what the nozzle looks like so far. Um, we're gonna have that bell design like SN3's nozzle. It's not gonna be a boxed out. This nozzle's gonna be tough because I would love to have graphite in it, but it's very hard finding someone to get graphite. Wait, let me just. I don't even know where the I don't even know where the chat went. If anyone is asking questions, okay, no one's asking questions, but still, yeah. So this is gonna be the nozzle. Most likely, I'm hoping to have a nozzle made out of a nozzle like SN2, learning off of what I've learned from SN2, having stainless steel and aluminum on it because I would love to coat stainless steel areas where it's going to be peak heating. And also, I haven't done any thermal analysis, which I would love to do some thermal analysis for this nozzle. But I'm not sure if stainless steel would even hold up in this configuration. I know it held up fine in the SN series, but we'll see. Um, here's a quick well, here's a picture. This is what Mega X's nozzle is looking like so far. Obviously, it's not gonna look anything like that when it's done. That's just a mock-up. There's gonna be O-ring grooves. There's gonna be holes for the radial bolts. My computer's beeping now, so I gotta put on an ice pack. My computer's broken, so it beeps whenever it gets hot. So I have an ice pack I gotta set it on. If you guys can hear the beeping, let me know. I don't think you will, but just let me know. Yeah, so here's Mega X's nozzle so far. Um, versus SN5's nozzle. It's pretty big. And yeah, here's the cross section. You can see SM5's nozzle can pretty much fit into Mega X's diverging nozzle end. I have it at I think a 3 inch or 3 inch or 3.5 inch exit diameter, which is optimized for sea level. I might go a little smaller though. I'm still running the simulations with that. Um, yeah, this is pretty much what Mega X is looking like so far. Hopefully, you guys can't hear this beeping because it's very annoying. Let me know if the stream's looking good. Um, so that's pretty much everything I have. This is just gonna be a quick stream, but if anyone has questions, please ask them below. I'll answer any questions about Mega X or anything. Um, yeah, that's what I got. Let me see if I got anything else. But yeah, looking at the first simulation, it's gonna be an I class rocket motor or L class rocket motor, sorry, which is yeah, it's gonna be crazy. Right now we're at around 7.5 pounds of propellant. Um, I may like to up that to maybe 10 pounds, which that's pretty ambitious. But we're gonna look into that. Yeah, as you can see on the left side, nah, you can't see on the left side the diameter, but yeah, right now we're at a 3.5 inch diameter. If we bump it up to 4 inches, we will probably not be able to get to 10 pounds of propellant, but maybe up to 9. Um, as you can see, the overall grain width or length will be 20 inches. You can see how the 3 inches will be the finishsill section, and then the rest will just be a normal core geometry, and those will be all casted together like I cast all of my other rackets for the SN series. Um, Yeah, so pressure is not looking like an issue right now. I'm actually hoping to increase internal pressure, but keep it in that safe range for the propellant and also for the casing. We're at a burn time of 2.91 seconds. I would like to try to extend that burn time, but it would be very tough. Rocket candy or um, potassium nitrate and sorbitol as I use. Um, that propellant is definitely not the greatest for burn time. It burns really quick. It's very hard to control the burn, but I'm going to do some research and I have some ideas to possibly control the burn to slow it down. But then if I slow down the burn, it will take away my peak. I want a peak thrust of around 500 pounds. But if I slow it down but keep it at a consistent high thrust, maybe I won't have a very high peak thrust, but I'll have a very high specific impulse, which is very important. Or, well, specific impulse, sure, but I mean total impulse. Um, so let's see, we can go through this again. Look at that. Yeah, it's gonna be. I mean, you can literally fit the SN series motors inside of Mega X's casing. It's gonna be pretty crazy. Um, what time for the completion? Well, I'm hoping to hopefully static fire by mid or end of August, which is probably pretty ambitious. But there's a lot of infrastructure that will need to go with this project. Um, first of all, with testing a motor this size, you got to be very safe. So I'm going to be building a recessed bunker. It's hard to describe. Pretty much a recessed bunker to light this off, so it's underground level. It'll still be open just to make sure if anything happens, nothing is going to hurt anyone. But yeah, I'm hoping by mid to late August, which is actually very soon. Um, but I hope to have it fully designed within 2 weeks. I think that's pretty achievable. So I'll give myself to July 26th. I'm looking at a calendar right now. I'll give myself to July 26th to have it fully designed. I'll order all the stuff. Maybe I'll probably order the stuff by the end of July. And then if I order the stuff by the end of July, parts will probably come in around the first or second. Well, realistically, I should probably order it by in two and a half weeks. Order within 2.5 weeks. So parts usually take around 2 weeks to come in. So hopefully I'll have the components by early July or early August. And then hopefully that gives me 2 to 3 weeks to have all the parts assemble and do some quick little tests and then do the whole integrated static fire by the end of August. Um, it's cool. It's a pretty ambitious test timeline, but I think it should be done. It should be able to be done. Let's get some more pictures. Just yeah. So the nozzle is probably gonna be the most difficult part, honestly, and also figuring out a new way to cast the propellant. I'm gonna use a very similar way that I have been using for the SN series, but rapidly change it. The SN series biggest rocket motor had 10 inches of propellant at a diameter of 2 inches. This is gonna have 20 inches of propellant at a 3-inch diameter or 4-inch diameter. So the biggest SN series rocket motor was SN3 within propellant and size. It was the biggest, and that had around I think a little bit more than a pound and a half of propellant. So I'm going from a pound and a half to 8 or 9 pounds of propellant. So this whole motor is gonna weigh probably around 10 to 15 pounds. Probably not 15, but yeah, it's another thing that I've been working on is a liner. I'm not entirely sure if we're gonna need a liner for this one. Just like my SN series, I don't use a liner. Sure, I use cardboard tubes I cast the propellant in, which sort of works as ignite or a liner. I mean, it gives a little bit of help. Um, but I may use thicker cardboard. I don't think I really need a liner for this relatively short burn. It's a short burn, a short burn, and it's a relatively cold burn. I say relatively. cold because it is very hot, but just relatively cold within other types of propellant. So I'm gonna work on that. Bulkhead will be easily be made out of aluminum, and then the nozzle that will need to be addressed somewhere. I would love to use, like I was saying, I'd love to use graphite. Because graphite's reusable, easy, and the best, honestly. But it's very tough to find someone or a company to do graphite for me. So that's why I'm probably gonna pair it with aluminum stainless steel, where the graphite parts will most likely possibly be stainless steel. Um, of course, everything I'm talking to is subject to change. This is all just a guess. Well, not a guess, but what my ideas are initially. Um, oh, not that. Going over the test site. Um, but yeah, it's gonna be tough. I'm gonna need to find out a way to bond the stainless steel to aluminum nicely, so I'm able to. Yeah, it's gonna be tough. Um, throw up. We'll throw up another. Throw up the isometric view. But yeah, I think that pretty much gets it for the live stream. If anyone has some questions, I'll give it a few minutes. Um, if you haven't, I'm guessing everyone in here has watched my video I just posted. But if you haven't watched that video, make sure to go watch it. Let me go over here, see how it's doing. 47 views so far. Not bad, not bad, not terrible. Oh, it still says premiere. I'm not updated. But yeah, it was a longer video. Let me know if you guys liked it. It's doing decent so far. Um, but yeah, this pretty much wraps it up for this live stream. Let me go over here. Let me see if I had any more questions. Oh, yeah. So this pretty much sums up the live